In section 4.1, we solved a system of two linear equations in two variables by three different methods. We used graphing, we used substitution, and we used elimination. Now what we're going to do in section 4.2 is we're still going to work with systems of two linear equations in two variables, but we're going to use matrices to solve. Okay, the reason being is methods like graphing and substitution and elimination, they work well when you have two equations and in particular two variables. But if you have a bigger system, those methods don't work as well. So for example, once you bump up to three equations, you usually have three variables, x, y, and z. And what happens is if you try to graph out your linear equation and it has an x, y, and a z and it has three variables, the graph is no longer a line. It's actually a plane. So think like a wall, okay? It's like a rectangular surface that extends in all directions forever. So you can't exactly graph that out, okay? So in order to solve bigger systems, you need a different method, okay? And matrices are the way to go, okay? But just to introduce you to matrices, we're going to work with the smaller systems first before jumping into the larger systems. So the first thing we're going to do is talk about some matrix terminology, okay? So again, this is section 4.2, systems of linear equations and augmented matrices. So under the matrix terminology, there's several words that you will hear. Okay, so we're going to go through those. Okay, first of all, what is a matrix? Well, a matrix is a rectangular array of numbers written with brackets. Okay, so under example 1, I have two matrices written down, so you can kind of see what a matrix looks like. Our book uses square brackets. You may have done this before, maybe in high school or something. Some books use large parentheses instead of large brackets. Either way, it means the same thing. Okay, so then each number in a matrix is called an element of the matrix. Okay, the size of a matrix is indicated by its dimensions. So if a matrix has m rows and n columns, then it has dimensions m by n. Okay, so when you're working with matrices, you really have to understand the difference between rows and columns. Okay, so I'm going to draw up here. So left to right horizontal, that's a row. Okay, and then up and down, that's a column. Okay, so remember this statement is kind of mathy, talking to you about dimensions. Dimensions can be very important, so you do have to know how to write them down. So it says if it has m rows and n columns, then the dimensions is m by n. So what you need to remember, and this is what I tell people, it's the number of rows by the number of columns. And the way to remember this, RC, think that matrices are really cool. Yay! Okay, so that means you're gonna, if you think really cool, rows are gonna go first and then columns. It's always row columns. Really cool. Okay, so hopefully that'll help you remember. All right, a couple more things before we actually do example 1 where we apply all this terminology. We name matrices with capital letters. Okay, so capital A, capital B, capital C, and so on would be the name of the matrix. And then whatever the letter you choose for the name of the matrix, the elements, the numbers inside, are named by the corresponding lowercase letters with subscripts indicating the row and then the column. Again, really cool. Everything is really cool. Row, column. All right, couple more. There's something called the principal diagonal. The elements on the principal diagonal of a matrix A are those with the same row number as column number. Okay, so for example, the number in the first row, first column would be a principal diagonal element because it's in the first row, first column, has the same row number as column number. Okay, or the number in the second row, second column, or the number in the third row, third column, and so on. Okay. Last piece of terminology, last bullet point there. A square matrix has the same number of rows as columns. Okay. Has the same number of rows as columns. It's called a square matrix. Okay. Not every matrix is a square matrix, but square matrices do have special properties. All right. So in example 1, I give you 2 different matrices, and we're going to go over all of this terminology that was just discussed. Okay. So in example 1, it says, answer the following questions about the given matrices. Okay, so let's concentrate on example A first. Here is our matrix. Okay, this is matrix A. Okay, it has 1, 2, 3, 4, 5, 6, 7, 8 elements, 8 numbers inside. Okay, first thing we're going to do is write down the dimensions. What size matrix is this? Okay, remember, you're going to do the rows by columns. Okay, so let's count the number of rows. Okay, this is row 1, 2, 3, 4. There are 4 rows. So you put that number first, and then you do the number of columns. It has 1, 2 columns. Okay, so this is a 4 by 2 matrix. Okay, always row by column, really cool. All right, then it asks for specific elements. See how this matrix is named capital A? Well, then if you're going to talk about the numbers inside, you're going to use lowercase letters. Okay, so lowercase a's to designate specific elements inside. Okay, so this first one, again, really cool. First row, first column. Okay, that's what this little subscript is telling you. First row, first column. Okay. So I'm going to find the number, and I'll try to color code these here. I'm going to go, let's see, first row, first column. Okay. So what element is that? -7. Okay. And then let's see, next one, we've got A2, 4. So second row, fourth column. Okay. So let's find the second row, and 1, 2, 3, 4. There is no fourth column, okay? So we are going to write undefined. There is no such element, okay? Because this matrix does not have 4 columns. All right, so now if we reverse it and we look at A42, so now this is talking about the 4th row, second column. Okay, that's better. Okay, that one's actually going to work, okay? So let's count rows. 4th row, 1, 2, 3, 4. 4th row, second column, that's going to be 10. Okay, so see the difference there. Okay, A24 is not the same thing as A42. Okay, you're doing rows by columns, always, always, always. All right, is this a square matrix? Okay, does it have the same number of rows as columns? No, because it has 4 rows and 2 columns. Okay, so this is not a square matrix. Okay. All right, so then last thing for this matrix, it wants the principal diagonal elements. Okay, so that means I want the number in the first row, first column. Okay, so that would be this, -7 would be one of the principal diagonal elements. And then I also want the element in the second row, second column, which would be right here. Second row, second column would be +3. Okay, usually you can draw in your principal diagonal. It's also called the main diagonal. Okay, you can usually draw it in. Just start in position 1, 1 and draw a diagonal. Okay, and catch everything, you know, in the same row, same column. Okay, so even though this is not a square matrix, you can still talk about the principal diagonal elements. Okay, all right, so only 2 of the 8 elements are on the principal diagonal. Okay, all right, so let's look at the second matrix. Okay, over here, I'll move it over a little bit. All right, so we've got a slightly bigger matrix. This is matrix B, okay? So the dimensions of B, okay? So we've got to count the number of rows. So 1, 2, 3 rows by how many columns? 1, 2, 3, okay? So it's got 3 rows, 3 columns, same number of rows as columns. So I'm gonna go ahead and say, yes, this is a square matrix, okay? All right, so let's identify some of the individual elements. Okay, again, this is capital B matrix. So all of the numbers inside would be referred to with a lowercase b. Okay, so this first one we want, again, really cool. First row, third column. Okay, so let's see here. We've got the first row, third column. So 1, 2, 3. That's going to be negative 37. Okay, and then B 3, 2. Okay, so this is going to be the third row, second column. Okay, so 1, 2, 3, third row, second column, so right here. So that's going to be 74. And then lastly, B2, 1. Okay, so that's going to be second row, first column. Okay, so let's find the second row, first column. That's going to be 400. Okay, so again, can't emphasize really cool enough. All right, last thing, we need the principal diagonal elements. Okay, so I need elements in row 1, column 1, row 2, column 2, row 3, column 3. Okay, so if we did that, okay, it's going to be these guys. Okay, so 14.5 and 8. Okay, so that's what a matrix is, and some of the terminology you will hear associated with matrices.